Hello guys, this is Prof and welcome to Tech Foundation Africa. I'm very happy to share with you once again. This is the second tutorial in our programming with C++ series. We ended the previous episode with a simple hello world program. Now, if you haven't watched that particular episode, please, I would advise that you do, because this takes off from where we ended in the other episode. Okay, so if you haven't watched it, just pause this particular video, go and watch it, then come back to it. All right, let's get started. Today I'm going to talk about the C++ program concepts, and this particular tutorial is based on the program we wrote. Okay, but I've actually modified it a little bit to include other things so that I can do more with this video. This is what I'm going to treat today. I'm going to talk about comments and whitespaces, preprocessor directives and standard library headers, functions, statements, data input and outputs, return statements, namespaces, names and keywords, and then how to represent numbers, or how C++ represents numbers, then ASCII codes, and finally we'll talk about escape sequence. So as you can see, we are going to do a lot today. I decided to put all this into one tutorial, so forgive me if this tutorial turns out to be very large, because I really want to get rid of these fundamentals and then start something that concerns programming. All right, so just bear with me and enjoy through the long minutes. So this is a sample program that I've written. Okay, so I modified what we did in the other one. So I'm going to use this sample program to talk about the things that I want you guys to know. Okay, if you look at this sample program, you can easily see that when we run it, it's going to display the text. The version of C++ used is 17. Okay, so now let's look at the parts of the program. We'll start off with the comments and whitespaces. The highlighted areas, where the areas with the red box around, we call them comments. Now I want you to pay attention to how the two boxes, how the comments in there differ. You realize that for the first one, the bigger box, we have a / and asterisk, and it ends with an asterisk and a /. In the smaller box, we have double /, and there is nothing terminating it. I want you to take note of that. So what are comments? Comments are actually added to document the source code to make it easier to understand how it works. See, most often when you are programming, a whole lot of ideas come to mind, so it leads you to write certain algorithms or certain codes. Okay, now if you don't put in comments to explain why you did that, give yourself a matter of weeks, months, a year, come back to that source code, and you'll be so confused about why you wrote that code. You wouldn't remember it that easily. Okay, or assuming someone else takes your source code to read, it is going to be difficult for the person to understand some of the things that you did. Okay, so by putting comments in code, it helps us to add explanations to the code so that whoever ends up reading the code would understand what we intended to do. Comments are actually ignored by the compiler. They do not play any role in the output of the compiler. Okay, so the compiler actually sees comments as whitespaces. The compiler actually sees comments as what we call whitespaces. Now, although adding comments actually makes the program great, if you add unnecessary comments, it turns out to be a nuisance, because it impedes readability instead of making the code great. Is that okay? Remember, too much of everything is bad. So in as much as adding comments to your program is a good practice, please just do it when it is necessary. Now, there are two types of comments. Okay, there are two types of comments. So as you saw in the beginning, one box or one comment started with a / and asterisk and ended with an asterisk and a /, and the second one started with a double asterisk. Okay, so there are two types of comments. Now the first one that I'm going to talk about is what we call the inline comment. The inline comment. So the typical example of the inline comment is what we have in here. Okay, the inline comment begins with double / and it can span only one line. The other type of comment is what we call the multi-line comment. Okay, and as you can see here, I'm able to write comments over multiple lines. Okay, so whenever you want to write comments over multiple lines, then you have to delimit them by / and asterisk, then asterisk and /. But if your comment is supposed to span just a line, then you just need double / and that will create an inline style or type of comments. Okay, now one thing is that the moment you use this / these delimiters, okay, anything inside this is treated as a comment. So you can't actually nest comment. You can't put a comment in a comment. No. So far as you have opened the opening delimiter and you have the closing delimiter, everything that will follow will be treated as a comment. So this actually gives you the ability to embellish your comment, decorate your comment, and make it stylish. Okay, yeah, that is if it is necessary. Now there are other forms of characters that are also considered as white spaces. Okay, to start with, any sequence of spaces, tabs, new lines, form feed characters are all treated as white spaces in C++. Okay, now the next thing in our code that I'm going to talk about is the line 7 #include IOStream. Now this is called a preprocessor directive. A preprocessor directive. Now let's look at what a preprocessor directive is. The next thing I want to talk about is the #include IOStream. It is called preprocessor directive. So let's look at what it is. So I'm going to talk about preprocessor directives and standard library headers. Preprocessing directives actually causes our source code to be modified in some way before it is compiled into an executable form. So the moment you hit on compile, the first thing that is done is that the computer invokes the compiler invokes the preprocessor, okay, which is a program. So that preprocessor actually processes all the added directives and make them available, so they are attached to your source code. Is that okay? So in this case, the preprocessing directive would add the content of the standard library header file with the name IOStream. Okay, because if you look here, we said include IOStream. So we are the preprocessor will go to the standard library and make read whatever is in this file and attach it to our code. Is that okay? It is going to attach it to our code. Now the header files that I'm talking about, sometimes you can call them headers. Okay, you can call them headers, and they actually contain definitions to be used in our source file. The IOStream library or header actually contains definitions that are needed to perform input from keyboard and also text output to the screen, okay, using the standard library routines or functions. Now things like std_cout and std_endl, among many other things, are defined in the IOStream header file. Now this means that if we should omit the IOStream, if we don't include the IOStream library, okay, but then end up using the std_endl and std_cout, then we are going to have compile time errors because the compiler will not know where to find those definitions. Any header file that you include, okay, and as we move ahead, you see that there are others. It's not always IOStream. There are other files like the cstd.lib. Okay, we'll be using them. So any of these that you actually include is added to your code. Is that okay? Use them when you need them. Okay, don't just be pumping in hash include this, hash include that when you have no need for them. Is that okay? Don't just be adding header files when you don't need them. Some compilers may or may not require spaces between the angled bracket. Okay, so this less than and greater than, they form what we call the angled brackets. Okay, now some compilers will require that you put space here and space there, but others may not. Is that okay? So you just have to know what your compiler requires, and then you do it as such. The next thing I want to talk about is the function. Okay, so the highlighted area is called the function. Now, what is a function? Every C++ program consists of at least one or many functions. So let's look at what functions are. To start with, a function is a named block of code that carries out a well-defined operations. So that is, functions consist of a group of statements that perform specific tasks. If you want to call or invoke a function to execute or run, you have to call it by its name. Now, all the executable codes in a program would have to appear within a certain function. Every C++ program must contain at least one function. Okay, so this one function that is supposed to be there by default, even if you are not doing any big deal, that function has to be present. We call it the main function. And to represent main function, I will always put the empty parentheses around it. Okay, so this function, no matter how simple your program is, every C++ program should contain this function. The main function always starts automatically when you run the program. Okay, any program statement that must be executed has to be either directly or indirectly linked to the main before it can be executed. Now, this means that if there is any executable statement in your source code that is not directly or indirectly linked to the main function, it will not be executed. Functions are also called subroutines in other programming languages. In object-oriented programming, something that we'll be treating very soon, we'll come across functions which are associated with something called classes. Okay, and when that thing happens, we call these kind of functions methods. Functions provide several important advantages. For instance, by using functions, you can break your code into functional units and stitch them together to form the complete program. Okay, now this makes it easy to test and debug your code, because you can know exactly which unit or which functional unit has the problem and attend to it. This method or this principle is informally known as divide and conquer. So by breaking the program into functional units, you can also reuse the functions at other places in your code, okay, without repeating the code in your source code. Okay, so let's say you have a function that reads input from the user, and you need this activity done in, let's say, 10 other places. In order to avoid repetition of code, once you define this reading of input as a function, then all you have to do is invoke them at all the other places that you need them without recoding the whole thing. So this is one of the benefits of using functions. Functions also make it easy to program in teams. Okay, usually when a team is working on a project, what they do is they split the project into logical units and assign them to different people. Is that okay? So once you create functions, the problem can be broken into functional structures, and each team would be assigned a unit or units to work on, and this cannot be achieved without functions. Without functions, that means all of you will have to sit together at one place and probably code together or something else. Generally, a function has two main parts. Now let me take you back to, okay, so we have int main followed by the parenthesis. We call this part the header. Okay, we call it the header. Then starting from this opening curly brace to the ending curly brace, we call everything in there the body. So a function has two main parts, the header and the body. In some programming languages, the header is also called the function's signature. Now the header consists of three main parts. We have the return type, which in the case of the function main or the main function is an int, which means an integer. Okay, and we know integers to be negative or positive whole numbers. The return type is followed by the name of the function, which in this case is main, and then a set of arguments which are passed through parentheses. Now for this function main, you realize that there is nothing in between the parentheses. Is that okay? There is nothing in between the parentheses, so we say that it has empty arguments. No argument has been passed. However, as we progress in these tutorials, we will pass some arguments called command line arguments to the main function. And when we talk of command line argument, these are arguments or values that you pass to a program as you run it at the command prompt or the terminal. Okay, so I'll do some demonstrations on that for you to understand what it means. Now the second part of the function is the function's body. Okay, the body consists of statements to be executed and the return statement. The closing and opening curly braces delimits the body of the function. So when we created a function, you realize that there was an opening brace and a closing one. So everything that falls within constitutes the body of the function. Now it is within the curly brace that you put all the statements that function is supposed to execute. So now, what are statements in C++? Statements actually form the basic unit of a C++ program. A statement always ends with a semicolon. It's like a statement in English where we end with a period. In programming or in C++, a statement, to end a statement, you use a semicolon. Okay, so the semicolon tells the computer that, hey, this is the end of this particular statement. In your source code, one thing I want you to remember is that it is the semicolon that marks the end of the program, not the end of the line. Okay, the end of the line doesn't matter in here. Now, what a statement does is that it defines the action, such as the computation that we want to perform. Is that okay? And everything a program does is usually specified in its statement. Generally, statements are executed in sequence, okay, from one line to the next, to the next, to the next, until there is a statement that causes that statement to be altered. Okay, now going forward, we will come across decision making and decision structures and looping structures, and you realize that actually the flow of our code or the flow of execution is not always going to be linear. Sometimes we can make decisions and branch. Okay, so apart from the fact that yes, there is something, another statement causing a change in the direction, by default our program's execution would be in a sequence, okay, from line 1 to the next, to the next, to the next, in that fashion. Now there are 3 statements in the sample code that we wrote. So on line 10 we have one statement. Remember, a statement ends with a semicolon. Okay, so on line 10 we have one statement. On line 11 to 13 we have another statement. Now you realize that we have 3 lines, but I said that's just one statement, right? So if you look at the endings, you see that the only place that there is a semicolon is on line 13. So that means that all these forms one statement. Remember, I said the end of a line does not mark the end of the statement, but rather the semicolon. Then the third or the last statement is the return statement, which is return 0. So our sample code actually consists of 3 statements. Now the first one defines what we call a variable. Okay, the first defines a variable, which is the name of a bit of memory for storing data of some kind. Now in this case, that is in our sample program, the variable has the name version, and it can store integer values. Now how do I know that it can store integer values? Remember, we wrote something like int version. Okay, the int there represents integer values, represent integers, which are negative or positive whole numbers. Is that okay? Now the space between the int and the version is very important, because if you omit it, then it is going to generate something else which the compiler will not understand. Is that okay? If we omit the space between the int and the version, that is going to create something the compiler does not understand, and is going to throw an error. Now inside the braces, after the word version, you realize that we have an opening and closing brace. Okay, and there is a value 17 in there. Now this value is supposed to serve as the initial value for the name, or for the memory space, the variable that we have created called version. Is that okay? So that is how you initialize things in the modern C++. That's one way of doing that. In a later video, we shall see other ways of doing that. On line 10, you can see that we have this inline comment here. Is that okay? Actually, this is very redundant, because anyone who knows programming knows that what we are doing here is defining a variable called version. Okay, there's actually no need putting this comment here. Okay, but then I place it there so that you know that you can actually put comments at the end of statements. Is that okay? So it's more of a demonstration than of a necessity. Another thing that you can do is that you can enclose several statements between a curly brace. Okay, between a pair of curly braces. Now when you do this, we call that a statement block, and the body of the function is an example of a block. A statement block is also referred to as a compound statement, because in most circumstances it can be considered as a single statement. Is that okay? So take it as you have many statements that you want to execute, but you want to treat all of them as one unit. Is that okay? Anytime you want to do such a thing, all you have to do is to wrap them in a pair of braces, an opening and a closing brace. The ability to put multiple statements in an opening and closing brace also gives us the power to replace single statement with a block statement. I will actually write codes to demonstrate all these things that I'm talking about, but I just want us to quickly do it, get rid of this PowerPoint stuff, and then get stuck with the IDEs that we'll be using for the coding. Okay, now as a consequence, blocks can actually be placed inside one another. Okay, we call it nesting. So you can put one block into another to any depth, so you can have so much or multiple nesting in your C++ code. But of course, you don't have to just do it for fun. It has to meet a need. You have to do it because it is something important that you want to implement in your code, not just for the fun of it. The next statement after the declaration, or the variable declaration, is an input statement. You can see std : cout. Is that okay? Now when we run this program, what happens is that it prints some characters to the screen. Okay, so how does it do that? In C++, input and output are performed using what we call streams. To output something, you write it to an output stream, and to input data, you read it from an input stream. Now a stream in computing, in computer terms, is actually an abstract representation of a source of data or a data sink. source produces, a sink takes. So that's the meaning of a data sink. Now, when your program executes, each stream is tied to a specific device. That is the source of the data in the case of an input stream, or the destination of the data in the case of an output stream. The advantage of having an abstract representation of a source or a sink for data is that the programming is the same regardless of the device the stream represents. Is that okay? You can read a DIX file essentially the same way you read things from the keyboard. Okay, now the standard output and input streams in C++ are called cout and cin respectively. Is that okay? And we don't pronounce it cout. We don't pronounce it cout. We say cout. Okay, it's an acronym that was coined from character output, and cin was coined from character input. Now, by default, your cout is tied to the computer screen, which happens to be the primary output device. Okay, and cin is actually also tied to your keyboard, which also happens to be your primary input device. Now, you realize that the statement on line 13, you can go back to the code to refer, okay, was spread over multiple lines. So it started from line 11 through line 13. Is that okay? So that is just to show you that is also possible until a semicolon is appended to the end of a statement. The statement hasn't ended, so take note of that. And that is to say that once you have the semicolon appended, you can stick so many statements on the same line, and it doesn't actually matter. But for readability purposes, please don't do that. Okay, for readability purposes, please don't do that. Now, the names cout and endl are defined in the iostream header file. Okay, you remember the hash include iostream. Now, the double less than sign is actually called the stream insertion operator, and whatever appears to the left of this stream insertion operator is transferred to the cout, or is transferred to the computer screen. Now, whenever you insert an endl to the cout, what happens is it causes a new line to be written to the stream, and the output buffer to be flashed. The output buffer is just a term for some area in memory where those characters are stored before they are printed to the screen. Is that okay? So if we are printing things to the screen, and the cout comes across a new line, all that it will do is that it will jump from the current line to the next line. That's the effect a new line or the endl has on the cout. Okay, it causes it to move to the next line on the screen, so that's why we call it new line. Now, flashing the output ensures that the buffer or the contents that you want to print appears on the screen immediately. Is that okay? So for instance, when we run the program, this is the output that we will get. Okay, the version of C++ uses 17, and we know that the 17 is coming from the variable version that we created. Is that okay? Now, finally, the last statement in the body of the main is the return statement. A return statement ends the function and returns control to where the function was called. Now, in the case of the main function, it ends the function and returns control to the operating system, because the main function is always invoked by the operating system. So if the return statement returns the handle to whoever calls it, then for the main function it will always return to the main operating system. So in your program, you don't explicitly invoke the main function. No, the main function is only supposed to be invoked by the operating system. Is that okay? Now, a return statement may or may not return a value. If you look at the definition, the header for our main function, it says that int main. Is that okay? So it's down there we have return 0. So returning 0 to the operating system actually indicates that the program ended successfully. There are other situations where you can actually return non-zero values like 1, 200, whatever that you want, to indicate other abnormal end in the conditions. For instance, you can put a return maybe 5 to show that there was no network. You can put a return of, let's say, 10 to show that there was no it failed at reading the database. So you can use the return statement just as a means of tracking errors in your program. So if a client calls you that my program is failing, you can just ask what is the return value that you get when the program is done executing. So if it says maybe 15, you the programmer, you know that 15 is associated to a file not found. Is that okay? So maybe you can advise the person that, oh, make sure that you have put the file in this particular place. Okay, so that is some of the things that you can use the return statement to do. All right, that is in the case of the main, but for other functions that we will be defining later, the return statement is a way of getting output back from the function that we create. Is that okay? And we shall look at those things in a future video. The return statement in the main is optional, so you could actually omit it. Okay, now this is because if execution runs past the last statement in the main, it is actually equivalent to returning 0. Okay, but please, one thing I want you to note is that it is only the main function that omitting the return statement is equal to returning 0. Any other function with a return statement like int always has to end with an explicit return statement. Okay, so take note of this. Now you keep saying std cout, std endl. Okay, what do this thing represent? Now before I come to that, assume you are in a class and there are 2 people called Eric. Okay, now your headmaster enters the class and says, Eric, come here. What do you think would happen? In this case, either both of them would stand or none, because they will be sitting down looking at each other, confused about who the headmaster is actually referring to. But let's say one of the Erics is fair and the other is dark in complexion. If the headmaster says that, fair Eric, come here, then now the fair, the word fair or the adjective fair now distinguishes between the 2 Erics, okay, and the confusion would be resolved. Now the effect of namespace in a program is similar to this analogy. Let's look at what namespace does in a code. Let's say you are working on a project with your team, okay, and the program has been broken into functional parts. Now this will potentially create a problem with names. Okay, this is because the same name might be used by different programmers for different things among the team, and this could at least cause some confusion and may cause things to go wrong. The C++ standard library, for instance, defines a lot of names, more than you can possibly remember. Is that okay? Now, accidental use of a standard library names could also cause a problem. Namespaces are designed to overcome this difficulty. A namespace is a sort of family name that prefixes all the names declared within the namespace. The names in the standard library are all defined within a certain namespace called std. Is that okay? That is why in the code you saw something like std : cout, std : endl. Is that okay? So we are trying to say that endl and cout are all defined inside the standard library, okay, in a namespace called what? std. Now the 2 colons form an operator called the scope resolution operator. Now this is something that I'll talk about in future videos when we start talking about object-oriented programming. Okay, now what the scope resolution does, it separates the name, which is std, from the names of that have been defined in the standard library namespace. Is that okay? So they serve as a separator. They resolve the names. Now almost all names from the standard library are prefixed with the std namespace name. Okay, now you can also create your own namespace. You can actually create your own namespace. Now one thing that you should take note is that when you create your own namespace, you should make sure that you don't accidentally include the main function in it. Now all things that are not defined in the namespace, if there is something in your code that is not defined in the namespace, then automatically it is in the global namespace, which actually has no name. Now there are some words that are exclusive to C++. This means that you cannot use those words in your program, okay, to name anything. Now these are called reserved words. Let's look at them. Our program contains a definition for a variable with the name version, and it uses names like cout, endl that are defined in the IOStream standard header. Okay, when you are writing a program, you will have to name a lot of things, and there are precise rules that you have to follow to define the names of stuff. Okay, now let's look at these rules. To start with, the name that you assign to anything should be a sequence of upper or lowercase letters. Okay, so capital A to Z or small a to Z, then the digits 0 to 9 or an underscore. So these are the only characters that are allowed in the name of anything. So aside this, no other character is allowed to be used in a name. Is that okay? Another thing that you should also take note is that a name cannot have space in it, and a name must begin with either a letter or an underscore. So these things are very key when you are creating names. Is that okay? Now C++ names are case sensitive. So for instance, in our program we define a variable called versions, all spelled in small letters. Now if I should create another variable called version, but this time I start the V with a capital letter, these two are different variables so far as C++ is concerned. This is because in C++ variable names are actually case sensitive, and this is not just C++. Most programming languages have the same rule. The C++ standard actually allows names to be of any length, but typically a particular compiler may impose some sort of limit. Okay, however, this is normally sufficiently large that it doesn't represent a serious constraint. Is that okay? So the amount of characters the compiler would allow you to use to name, sometimes there will be limits on it, but per C++'s definition, there shouldn't be. C++ does not play a limit on the length of the names that you select, but your compiler may put a constraint on it. Is that okay? And most of the time you won't actually need to use names of more than 12 to 15 characters. Come on, if you are creating variables and you are writing sentences as names of variables, typing is going to be an issue for you. Okay, so usually you keep it simple and sweet. The other thing I want to talk about is keywords. Now keywords are reserved words that have specific meaning in C++. This means that you must not use them for any other purpose. Examples of keywords include the word class, int, using, include, catch, and many others. Okay, now there are other names that you are not supposed to use in your C++ program. This includes names that begin with 2 consecutive underscores. Don't do that, and I'll tell you why you shouldn't do that. Now, names that begin with an underscore followed by a capital letter should also be avoided. Within the global namespace, all names that begin with an underscore, you should avoid it. Completely stay clear of starting the names of your variables or your identifiers with underscores. Don't do that. Okay, now why do you have to do this? The compiler often won't really complain, okay, if you use these if you use these things. Now the problem is that such names might actually clash either with those that are generated by your compiler or with the names that are used internally in the standard library implementation. Is that okay? Now notice that the common thing about these reserved names is that they all start with an underscore. So that is why I said that to be on a safer side, don't use names that start with underscore. You may be playing games, working on a docs or a Word document, watching a movie, but you see, behind the scene, the only thing the computer is doing is crunching some numbers together. The computer doesn't know anything called A or B or C. All the computer knows is numbers. Is that okay? Now, numbers in C++ can be represented in different number of ways, and knowing all the possibilities is very important, as it can save you a lot of time. Okay, it can save you a lot of time. So let's look at this, how numbers are represented in a C++ program. Let's start off with binary numbers. Human beings are actually comfortable with decimal systems, and when we talk of decimal systems, we mean base 10. Okay, so we actually represent our numbers, we count in base 10, and this could probably be because we have 10 fingers and 10 toes. Is that okay? So we can use them for counting. Now the computer, however, is built mainly on switches, and that can only be in either one of two states. So it can be on or off. Is that okay? So this is why computers represent numbers in base 2 rather than base 10. Base 2 is called the binary system of counting. Okay, numbers in base 10 have digits from 0 to 9, whereas numbers in base 2 have only 2 digits, that is 0 and 1. So this means that for a given base, the available digits are all the digits below the digits of the given base. Is that okay? So if I say work in the base 8, then the digits that qualify will be 0 up to 7. If you are working in base 5, the digits that will qualify will be 0 up to 4. If you are working in base 3, the digits that will qualify will be 0 up to 3. Is that okay? So that is what I mean by that. A binary digit is commonly known as a bit, and it refers to 0 or 1. There is something called ASCII, which stands for American Standard Code for Information Interchange, and is a common way, or is the most common format for text files in computers and internet. Now, in the ASCII representation, each alphabet, numeric or special character, is actually represented by a 7-bit number, and this 7-bit number is a string of zeros and ones. Using the first 7 bits, you can represent positive numbers from 0 up to 127, okay, which will give you a total of 128 different numbers. Now, using all the 8 bits, you can get a total of 256 numbers. In general, if you have n bits available, you can represent 2 raised to the power n number of integers with positive values, okay, from 0 up to 2n minus 1. The binary notation, however, in human perspective, is a little cumbersome for practical use, okay, particularly when you are working with bigger decimal numbers. Now, clearly you need a more economical way, or we need a more economical way of writing this, okay, but then you may think that the decimal system would be appropriate, but it is not. There is an easier solution, which is called the hexadecimal notation. In the hexadecimal notation, numbers are represented using base 16. Arithmetic in base 16 is much more convenient option with binary. Each hexadecimal digit can have values from 0 up to 15, and the digits from 10 up to 5 are represented by letters A up to F. Is that okay? Now in C++, hexadecimal values are actually written starting with 0 and X. They are prefixed with 0 and X. The X can be capital or small. Is that okay? So if I have 89, it is not the same as 0x89. 89 is just base 10 representation of the number 89, but 0x89 is a base 16 representation of whatever number that is. Okay, so take note of that. So there is another aspect of binary arithmetic that you need to understand, and that is negative numbers. How is a negative number represented in a modern computer? This is a question that requires attention. Now, integers can be both positive and negative, okay, and we refer to them as signed integers. Unfortunately, we only have binary digits at our disposal, okay, to represent numbers. Now, at the end of the day, any language your computer speaks shall consist of solely the bits and bytes. To solve the issue of representing negative binary numbers, the computer assigns a fixed number of bits and designates one of these bits as a signed bit. Now, in practice, the signed bit is always chosen to be the leftmost. The signed bit is always chosen to be the leftmost bit. So, for instance, positive 6 is represented as 0000110. Okay, to represent minus 6, all you have to do is to change the sign bit, which is the leftmost bit, to 1. Is that okay? So 0 means positive and 1 means negative. This is called signed magnitude representation. Each number consists of a signed bit, that is 0 for positive values and 1 for negative values. Okay, and it also has a given number of other bits that specifies the magnitude of the number. So if you have the extended ASCII scheme, which consists of 8 bits, the 1 bit, which is the leftmost bit, is used to represent the sign, and the rest of the bits indicates the number, the magnitude of the number that we want to represent. So anytime you see a 0 as the first at the leftmost position, it means that that number is a positive number. If you see 1, it means that the number is a negative number. So this is how you can easily track which binary numbers or digits are positive or negative, or which ASCII code representations are positive or negative. Another scheme of representing numbers is the octal scheme. Digits in an octal value can only be from 0 to 7. The octal value system is actually rarely used these days. Okay, it was useful in the days when computer memories was measured in terms of a 36-bit word. The reason I am talking about this is because of the potential problem it can cause in C++. Okay, now in C++, octal values are written with a leading 0. So if you have something like 76, it is a decimal value, but if you have 076, it is an octal value corresponding to the number 62. Is that okay? So here is the golden rule: never write a decimal integer in your source code with a leading 0. Okay, the moment you put a leading 0 in a decimal number, it automatically becomes an octal number. So this is something that you should pay attention to. Then we also have what we call the floating point numbers. All integers are numbers, okay, but of course not all numbers are integers. Now the value of pi, for instance, which is 3.142, okay, it's not an integer. Now, most of the applications that you'll be writing in C++ will have to deal with fractional numbers at one point or another. So clearly, we need a way to represent such numbers, okay, on our computer as well. and we also need a way to perform computations efficiently with them. Okay, the mechanism that nearly every computing system support, okay, for handling fractional numbers is called floating point numbers. Now, floating point numbers do not just represent fractional numbers, but they can also deal with very large numbers as well. Floating point numbers may have a decimal point in them or an exponent which represents multiplication by powers of 10. Now, the letter E or capital E is used to represent the exponent. Floating point numbers may have a decimal point in them or an exponent which represents multiplication by powers of 10. Okay, now the letter E or capital E is used to represent the exponent. They are actually called floating point numbers because the decimal point floats, okay, in the sense that the position of the decimal point depends on the exponent value. Okay, and floating points in general only approximate, they are approximate representations of exact values. Okay, for instance, remember that the value of pi is non-terminating. Is that okay? So if I save 3.142, for instance, that is an approximated value of pi. Is that okay? And usually that is what floating points numbers, that with the exception of a few cases where you have exact division or exact output, most of the time floating point numbers are approximated values. Okay, and because of this, care must be taken when you are performing computations with floating point numbers. You should seriously pay attention to certain details. Now let's look at ASCII codes. How are characters, letters, symbols, and keyboard commands like backspace, okay, represented in computer? Let's look at that. So ASCII stands for American Standard Code for Information Interchange. Okay, we've come across this previously, and it is a means of representing characters. ASCII codes are 7 bits in length, so there are 128 different code values that they represent. Okay, now values from 0 to 31 represent various non-printing control characters such as carriage, return, line feed, and the rest. Okay, then we have codes from 65 to 90, which represents the characters capital A to capital Z. We also have from 97 to 122 corresponding to the lowercase letters. Is that okay? Now, if you look at the binary values corresponding to the codes for the lowercase and the uppercase letters, you realize that the seed bit is what changes. Okay, the seed bit is what changes. The seed bit in the pattern is what changes. So the lowercase letters have a seed bit that is 0, and the uppercase letters have a seed bit that is 1. Okay. Other codes represent digits from 0 up to 9, punctuations, and other characters. Now, ASCII can only handle characters in the English language. When it comes to languages like French and German, where you need things like the accent, then the ASCII will fail because ASCII values do not include those characters. So to overcome these limitations imposed by the 7-bit code, an extended version of the ASCII was actually defined, okay, with 8-bit codes, okay, 8-bit string of binary codes. Now, values from 0 up to 127 still represent the same characters as they do in the 7-bit ASCII scheme, okay, but then values from 128 to 255 actually are variable. Okay, they are variable. there are other character encoding schemes that can handle more than the ASCII. We have Unicode, we have UTF-8, UTF-16, and all those things. Now, I want you to do a simple Google search and read about them. Now, when we are writing our C++ source codes, okay, there are certain characters that we are allowed to use. You write C++ statements using basic source character sets. We call them source character sets. Now, this is a set of characters that you are allowed to use explicitly in a C++ source file. The character set that you can use to define a name is a subset of this source character set, okay? And of course, the basic source characters in no way constrains the character data, okay, that you work with in your code. In your program, you can create strings consisting of characters outside source character sets that C++ defines. Is that okay? You can define characters outside this source. The basic source character set consists of the following characters. So first we have the letters A to Z and capital A to Z. We have the digits 0 to 9. Then we have some white space characters, okay, like the space, like horizontal tab, like vertical tab, form feed, new line. Is that okay? Then we also have these symbols, okay. You've been seeing underscore, curly braces, square brackets, the hash, as in hash include, the parentheses, less than, greater. So these symbols are all used in C++, so they form what we call the source character set. Is that okay? So in total you have 96 characters that you can use, and it's likely that this will accommodate your needs most of the time. But then in case or occasionally, if you need character sets or characters that aren't defined in it, you can actually, in theory, include Unicode characters in your names, okay? And if you want to know much, you can Google it and learn how to do that. So this is a chart showing you the ASCII characters that we have. So for instance, space, okay, when I hit the space bar on my computer, the ASCII value associated with it is 32. Is that okay? The number 0 or the character 0 is associated with ASCII character 48. 9 is associated with 47. Capital A starts from 65. Capital Z ends at 90. Okay, small letter A starts from 97, and small letter Z ends at 122. So if you like, you can actually download this this ASCII chart. I don't know what you do with it, but if it fancies you, you can actually download it and print it and paste it somewhere. Okay, so we have something called the null character. Okay, null character, that's ASCII character 0. Is that okay? What else? Now if I press backspace, for instance, it's ASCII character 8. So when you press backspace, what the computer actually sees is ASCII character 8 and not backspace. Okay, cancel, where is escape? So if you press the escape button, this is what the computer sees. It sees the number 27. It sees the number 27. Okay, now finally on today's list, let's look at escape sequences. When you want to use character constants such as a single character or a character string in a program, certain characters are quite problematic. Okay, now we call something escape sequence. An escape sequence is a sequence of characters that does not represent itself when used inside a character or a string literal, but it is translated into another character or a sequence of characters that may be difficult or impossible to represent directly. So an escape sequence is an indirect way of specifying a character, and it always begins with a backslash. So these are the common escape sequence. So we have \n. So if you do \n, the compiler will interpret it as a new line. \t is a horizontal tab. Okay, it's like pressing a tab on your keyboard. Then we have /a, which will give you a beep. Okay, it will give you an audible bell sound, which will be the default beep sound on your operating system. Then we also have /r for carriage return. Those who have seen a typewriter before, there was this button that if you press on it, then the paper will reset to the beginning position. Okay, that's how carriage return works. Okay, then when you want to represent / itself, because it starts an escape sequence, to use / itself in a string literal, you have to / it, you have to escape it to tell the computer that, hey, I don't want you to treat this as the regular escape sequence, I want to print a normal / character. So the / character, like I said, is difficult because it signals the start of the escape sequence. Okay, single and double quote characters are used as delimiters, as in a constant. Like if I want to represent, let's say, capital A, I have to save it as a character. So what you do is you wrap it inside a single quote. Is that okay? But if you have more than one letter, for instance, if you want to save the name Eric in your code, then you have to wrap them in a double quote. So single letters are called characters and we wrap them in single quote, but multiple letters or string of characters are called strings or string literals, and you wrap them in double quotes. Is that okay? Now, because the / signals the start of an escape sequence, the only way you can enter a / as a character constant is by using the successive /. So double / like I showed in the table. Is that okay? Or as we have here. A string of characters between a pair of double quotes is called a string literal. Okay, so as we have in here, you see that we have double quotes and then double quotes. So that makes this a string literal. But if you come here, we have single quotes, and this is called a character. Okay, so all single characters are represented or delimited in a single quote. When you put many of them to form names, words, sentences, then you have to wrap them in double quotes. The double quote characters are delimiters that identify the beginning and end of a string literal. Okay, but then they aren't part of the string itself. Now, each escape sequence in the string literal will be converted to a character that it represents. Okay, to be converted to the character that it represents by the compiler. So the characters will be sent to the output or the cout, not the escape sequence itself. So for instance, if you use the new line /n, it is not the /n that will get to the screen, but then remember /n was represented by, I think, the value 15 or something. So it is that code, that character that they represent, that the computer is going to send to the screen. Is that okay? That's what the computer is going to send to the screen, not the escape sequence itself. Alright, this has been a very long but necessary journey. These kind of fundamentals are worth spending time on. Once you understand this basic stuff, the rest is easy peasy. Now, I want to express my gratitude to our sponsors and partners. ASCII is a company that designs and builds smart agricultural machinery suited for African conditions and use. They also provide fabrication training services and computer-aided designs, what we call CAD services, okay, to manufacturing industries. So those of you who are into CAD, you can call them for advice or for project assistance. Okay, those of you whose parents or who own large farms, if you want machines, tools for your farm, if you want to mechanize your farming, then ASCII is the right people to call. Okay, then we have Tech Technologies and Pescan Enterprise. These are electronic retail shops in Kumasi. Okay, if you need components to build your circuit, any components, any kind of component, just give them a call. Tech is at China House at Adum, Kumasi, and Pescan Enterprise is at Achemfo Market in Kumasi. Electronics designs smart electronic systems, IoT systems, web applications, software, project assistance, and also we provide IT training services. Okay, now Tech Foundation is forever grateful for your support and keep it coming. All right. So we want to be able to reach out to more people and also give you awesome learning experience. Okay, you can see that my microphone, the sound that my microphone is producing is not the best, but then what can I do about it? Gradually we'll get there. Okay, so we actually need your support, guys. Your support is very much welcome. If you want to sponsor or partner with us, you can also reach us on info@techfoundationafrica.com, or you can call 00233-553-988-118. If you can send us any amount via mobile money to support us, we will be glad. Any amount from 5 cedis to $5 million will be accepted with a good heart. All right, guys, I'm very tired. This has been a very long journey. So this is the end of the tutorial. Don't forget to like and subscribe to this channel. If you have any comment, please leave it in the comment box below, and we will attend to it ASAP. Okay. All right. I am Professor, and this is Tech Foundation.